Hello guys, welcome to the comprehensive video series of Information Theory and Coding designed for the final year BTech and CCIT student at Makaut. In this series, we will explore the essential concepts that form the backbone of the modern communication system. Information theory helps us to understand how information is transmitted, processed, and compressed, while coding theory focuses on error detection and correction. From source coding to convolutional code, the subject bridges the gap between the theory and the practical application in the telecommunication, data compression, and the secure communication. By the end of this series, you will gain a solid understanding of key concepts, theorems, and the real world coding techniques. So, let's begin this journey into the world of information and coding. Okay. At first, the information theory and coding form the theoretical framework for understanding the data transmission, compression, and the error correction. This field emerged to solve the problem of how to efficiently encode and transmit the data over the noisy communication channels. Key concepts such as the entropy, the mutual information, and channel capacity are introduced in this section. The main objective is to optimize the representation of information to ensure the reliable communication. This forms the basis for later topics like the source coding and the error correction coding, which will be covered in detail throughout the series. By exploring these, you will gain insights into how communication systems handle the large volumes of the data within the minimal loss. So now the source coding. Source coding deals with the process of converting the information into a format suitable for transmission or the storage while minimizing the redundancy. Central to this concept is a measure of entropy which quantifies the uncertainty in the source. The source coding theorem establishes the limits of the data compression. We will explore the techniques like the Huffman coding, which provides an efficient way to encode the data by assigning the shorter codes to more frequent symbols. This section will also dive into the concept of average mutual information, a key measure for understanding how much information can be transmitted efficiently. Understanding these principles is vital for building the systems that handle the large data volumes without unnecessary overhead. So now the channel capacity and coding. In this section, we focus on how to transmit the information reliably across the communication channel. The concept of channel capacity describes the maximum rate at which information can be transmitted with the minimal errors. The Shannon capacity theorem defines the theoretical limit for the data transmission over a noisy channel. Channel coding refers to the use of error detecting and the error correcting codes to ensure that transmitted data is accurate, and the Shannon limit defines the maximum achievable data rate for a given channel and noisy level. This section also lays the foundation for understanding the practical error correction strategies, which will be explored in the later topics. So now the linear and the block code for the error correction. Linear block code are a fundamental tool for error correction in the digital communication system. These codes are represented using the matrices and provide a systematic way of encoding the data. The parity check matrix helps to identify the errors in received data, and decoding these codes allows for error detection and correction. We will cover the Hamming code, one of the simplest linear block code which can correct the single bit error. Perfect code are also discussed, which have the optimal ability to correct the errors for a given code length. This section is essential for understanding the how to maintain the data integrity during the transmission and improve the communication reliability. So now, cyclic codes. Cyclic codes are a class of linear code that are closed under the cyclic shift. These codes have several practical advantages such as ease of implementation and the error detection capabilities. The division algorithm for polynomials is key to understanding how these codes are generated. We will also explore how the matrix representation of the cyclic codes help in encoding and decoding the data. So the Golay code, a type of cyclic code, are particularly known for their error correction performance and are discussed in this section. Cyclic codes are widely used in the error correction systems such as CD, DVD, and the other digital communication system. So now the BCH code. BCH codes, names after their inventors, are the family of error correcting codes that can correct the multiple errors. This section will introduce the concept of the primitive element and the minimal polynomials, which are fundamental to constructing the BCH code. Generator polynomials are derived from the minimal polynomials and used to encode the data efficiently. BCH codes are particularly useful because they offer the flexibility in collecting the multiple errors, making them ideal for use in the systems that require the high levels of error correction. Real world applications of the BCH code include the deep space communication and the data storage system, and where the error resilience is critical. So now the convolutional code. Convolutional codes are a type of error correcting code that processes the input value or the input data stream into a continuous manner. Unlike block codes that work on fixed size data block, okay, we will discuss the tree and the treeless code, which visualize the state transitions of a convolutional encoded. The polynomial description of the convolutional code helps in understanding the encoding process, while the distance metric allows us to measure the performance of these codes. Decoding the convolutional code is more complex and involves techniques like the Viterbi algorithm. The turbo codes, a modern class of the convolutional code, are also explored, showcasing the advanced error correction methods that offer near optimal performance in the communication systems. See, these terminologies can be hard for this time, but we will deep dive or also provide the notes of this subject. Okay. So thank you for watching the introduction of information theory and coding. We have touched on the key concept that lay the foundation for the detailed lessons ahead. As you progress through this series, you will deepen your understanding for the error correction, data compression, and efficient communication system. Remember, this subject is not just theoretical, it plays a pivotal role in the modern technologies like the wireless communication, the cryptography, and the data storage. Keep exploring, practicing this concept, and soon you will be able to apply these techniques to solve the real world problems. Stay tuned for the next video. Then don't forget to like and subscribe for the more updates.